So when you're working, if it isn't making sense to you, these steps of FOIL, you have that example at the bottom of the page, of page 423, to use as a guide also. Okay, so anybody not get a copy of the notes? Oh, this would be Julia's if she were here, wouldn't it? Okay, so our learning goal today is how to multiply a binomial by another binomial, and we're going to use a method called FOIL. So the first thing we're going to do, just like we do every time, is we're going to rename subtraction to add the opposite. So you look at your binomials and decide, do you have to rename either of them or both of them or neither of them? So we have any renaming to do in this one? Okay, we're going to rename the first one? Second one. So we're going to leave the first one like it is, x plus 1, and the second one's going to change to what? What's its new name?
X plus minus plus.
Took a weekend off and look what happened. Okay, x plus negative 2. Now, here's what's going to happen. If you seriously think you have this all figured out and you're going to do multiply without changing to add the opposite, then you better really know what you're doing. Because when there's 4 multiplications going on, and there's a subtraction or more, maybe there's 2 subtractions involved, it will cause some kind of, a little bit of chaos if you don't know what you're doing. So what does the F step stand for in FOIL? What multiplication are they describing there?
First term.
First term. So the first times the first. Okay? So in other words, the first term of each polynomial gets multiplied. So what's our F step going to look like? X times X. The first terms are going to be multiplied times each other. So it's kind of like saying there would be our first distributive arm. That's really what would be going on. Okay, what's the O step stand for?
Outer term.
The outer terms, okay. So what would the outer terms be?
X and negative 2.
So the outer ones, oh, I should be doing it over here in my renamed one, not up here. I don't know what I was doing there. Okay, so X times X, and that was that arm. And then we said for the O term, you want the outer. So you said the outer terms are this X right here and this negative 2?
Yep.
So in other words, this X is now going to be distributed to that term?
Yes.
So X times negative 2. Okay, what's the I step stand for?
Inner.
Inner terms. So what are the inner terms, Abby?
1 and x.
So this 1 and this X get to be claimed as the inner terms. Okay, so this 1 and this X, they're the inside. So there's our distributive property taking now the second term times that first term of the other one. So 1 times X. And what's the L stand for?
Last.
Last terms. So what's our last terms in this one, Aurora?
1 and negative 2.
1 and negative 2. So the last term of that one, last term of that one, there's our fourth distributive property really, 1 times negative 2. So this X in the beginning got multiplied times the X in the other one. It also got multiplied times the negative 2. Then we come back and say, but now we got that other term 1, it has to be multiplied times that X, and it has to be multiplied times that negative 2. The FOIL process makes sure all 4 of those multiplications happen. Now what we do is we say, okay, what do these become? X times X is?
X plus X is
X squared.
Yeah, X squared. X times negative 2 is?
negative 2x.
Negative 2X. 1 times X is?
1x.
1X. And 1 times negative 2?
Negative 2.
Negative 2. So we now have an addition problem. We really have, and I want you to bring it down like this, x squared plus negative 2x. We have to add all of our multiplications together. So our 4 products that we got become an addition problem. All of those products have to be added together. Which ones really, truly can be added together?
Negative 2x plus negative or plus 1x.
Typically what will happen, notice I didn't say always, typically what will happen is the 2 inside ones, the O and the I step, The O and the I step in the middle will be like terms, and they will be able to be added together. So what is negative 2x plus 1x?
1x. Negative.
Negative 1x plus our negative 2. So we were able to combine the O and the I steps because they were like terms. Typically, we can do that. Not always, but typically, especially when there's only one variable involved. And then how could this be cleaned up?
X squared minus 1.
X squared minus,
1x.
nope,
X.
x, they wouldn't even have a 1 in there in the answer bank, and then minus 2. This is how we would see it in an answer bank. We gotta know how we would see it. Okay, questions? Okay, then let's move on. What's x plus 1 in parentheses with a squared outside of it mean?
X
X plus 1
times x plus 1.
times x plus 1. Let's write it that way so that we're going to be able to see our first, outside, inside, last. So we need an F, we need an O, we need an I, and we need an L. We need 4 multiplications. Go ahead and do it. Let's see what happens. Your F step, O step, I step, L step. Set it together as an addition problem when you're done. Clean it up. And see if we all get the same answer. You should all have the same multiplications. No other choices here. Okay, what's the final result? Cleaned up.
X squared plus 2x plus 1.
Everyone agree? What you got? Make it happen or ask questions. Okay, just a little preview of what's coming up in the next chapter. Just a little preview of what's coming up in the next chapter. We're multiplying now. They don't really call it this, but this is what we're going to do in the next chapter. We're going to unmultiply. In other words, here's what they're going to do to us. They're going to give us the polynomial result, the product of something, and they're going to ask us to factor that. They're going to ask us to unmultiply it. Well, guess where we should be able to get it back to? Right here, before we did FOIL it, right here. We should be able to get it back to that. Oh, that came from x plus 1 times x plus 1. And the reason I tell you this is because while you're doing your multiplying, I want you to, I want you not just to do the multiplying, but I want you to go through kind of like, start trying to make sense of all the parts and then, oh, this always seems to happen. This is something that I can count on. And then that's going to make factoring that much easier. Is factoring a big deal? I wish I could have, anybody know Casey Lloyd? She's in college now, this is her first year in college over at Jamestown. Courtney Laurie's older sister. I wish I could have her here because she said to me, I need to come and stand in front of your classes. I need to tell them that when they were, like when they're 9th and 10th graders, and you're standing there saying that factoring is the most important skill you need to learn, that you are not kidding. She's in college now, doing factoring and pulling her hair out. She's like, Mom, why can't I remember how to do this? I said, because I guess you didn't take it seriously. So I've been helping her some, but it's huge. We have to understand, because you're going to use it in geometry, you're going to use it in other algebra classes you're going to take. It depends on what you do from here on out. So again, this one right here, x squared minus x minus 2, they would ask you to factor that. In other words, they're going to say, what was this before you multiplied it out? What did this come from? Well, this came from this up here. Okay? So kind of just start trying to make some connections between what it started as and what it ended up as, because now when we get into chapter 7, we're going to reverse that cycle. And it's important. It's really important. Okay, let's go to the back side and see what we got back here. This is x minus 2 in parentheses with a square outside of it mean. What does it mean? Tori, what does that one mean? How are we going to rewrite it?
X minus 2 parentheses, and the same thing.
Okay? So it really means take x minus 2 times itself, right? And so can we change it to add the opposite also? Or should we?
Yes.
Yeah, we should. Okay, so now we have our x plus negative 2 times x plus negative 2, and now you can go ahead and do your FOIL steps. Okay, go ahead and do those. Because the more I make you just do it on your own, you're just not copying me, then it's gonna click. Cody, are you done? You go on and take paper, then you do it on the board. You pick the color you want to write in, and you do it with your finger, right? I want to see something's happening. Oh, outside. Outside. Oh, it's not recording. Do it. You got this.
You want me to solve it?
Yep, finish. Do the whole thing. Scroll that down a bit for you. Yeah, good. So now what do you do next? Yes, Mikhail?
I disagree.
What do you think it should be?
X to the second plus 4.
Plus 4 instead of minus 4?
Oh,
Okay.
yeah. I agree.
So we're gonna change.
Yep.
Okay, you want this changed to a positive 4?
Yep.
Which would make this a positive 4, which would make that a positive 4, which would make this plus 4?
Yep.
Okay, you guys all agree now? Everybody agrees? Aurora?
Disagree.
You disagree. Well, good for you, because you should. So, Aurora, where do you want to challenge this and say, you know what? I think it's wrong at that point. Do you want to just come up and show? You can just circle where it is and put what maybe your paper has instead. You can put your paper if you need to. So I think he probably agrees with you to a point here, doesn't he? Can you tell where it breaks down? So can you circle, I changed it to black, can you just circle in there where you think you went wrong? Yeah, I think you're right, it's right there.
And then put my
Yeah,
answer.
and above it, would you just, or kind of, yeah, above, off to the right, whatever, just kind of put what you have there instead? Okay, and then what would your answer, just give your complete answer and circle your answer, and yours will be in black. Look at yours in that. See if anybody else agrees with you. Okay, thank you. Anybody agree with Aurora? Yeah, you're all good. Yeah. Okay, thank you, Aurora. It is not x squared plus 4. And one thing I want, and I'm actually kind of glad that happened because I've had college students that have taught through college multiplying, and they've tried to shortcut this problem, a problem like this, and the problem we just did on the front side, the bottom one on the front side. Here's what students sometimes want to do. They want to say, you know what, seriously, I do not need to go through all 4 of those steps. These are the same, so all I need to do is change this to add the opposite, and I just need to take x times x and negative 2 times negative 2, and my answer will be x squared plus 4. But did it turn out to be that?
No.
No. I mean, it did, but it was wrong. Because negative 2x plus negative 2x is not 0x, is it? No, negative 2x plus negative 2x. And then I'm going to go back to this one, that one on the bottom front here. I'm going to go back to that, and I'm going to say, you know what, again, students are like, oh, it'd be crazy to go through all those steps of FOIL. You can just take x times itself, and you can take 1 times itself, and add them together, and that'll be your answer. X times x is x squared. 1 times 1 is 1. So using that thought process, our answer would be x squared plus 1. Is that what we got?
No.
No.
You'd have to multiply. If you're gonna do that, you're gonna have to have a 2 to it, but you would be done because you couldn't find a 2.
You can find a 2, and you'd be like, well, where did that 2x come from when you're trying to take a shortcut like this? So, note to self, no shortcuts like that. You don't get to do that. You still have to do these steps. There are some, what we call special products where you can take shortcuts. This is not one of them. This is not one of them, nor is this one back here one of those where you could take a shortcut and say, oh, take x times x and take negative 2 times negative 2, and presto, my answer is x squared plus 4. No shortcuts. You can't do it. Okay, so we figured out where the mistake went. Anybody have any concerns, questions? Everybody got that? If you didn't, you changed it. Okay, so we're gonna go with, Cody had everything right up to here. Aurora says no, scratch Cody's, I'm gonna put a negative 4x there. Scratch that answer, my answer is gonna be that instead. Okay? Okay, You ready for the next one? Let's do it together. First of all, we're gonna rename that as 2x, does that one need to be renamed? The 2x plus 3?
No.
No. Okay. How about the 4x minus 5? Yes. Okay. Okay. F step, O step, I step, L step. Okay, what's our F step look like for this one?
2x times 4x.
2x, first one. 2x times 4x. Let's just do let's not even find the products yet, okay? What's our O step look like? Need to hear from another country. Kelvin.
2x.
Oh, okay, go ahead, Noah.
2x times negative 5.
Okay, 2x times negative 5, the outside ones. 2x is outside, negative 5 is outside. Devontae, how about the I step?
3 times 4x.
3 times 4x. I stands for inside, inside, inside. 3 times 4x. And the L step, Calvin, coming back to you. L stands for love is in the air. Huh? Last. Okay. Last. And so what would that be?
-5.
Okay, negative 5 times.
4x.
No, the other last one.
Oh, 3.
The last of each term, of each polynomial, that's what it means. So 3 times negative 5. Last. Last term of each. So 3 times negative 5. Okay, now let's do our multiplying. 2x times 4x.
8x.
2 times, see, I was hoping you were ready to not have to rearrange. What do we do when we take a monomial times a monomial?
Add them together. Or will you?
No, 2 times 4 times x times x.
Yeah. Now, I'm if you're at the point you don't need to show that, you can actually multiply correctly. You say, I can take the constant times the constant, the x times the x. 2 times 4 is 8. X times x is
8
x squared. That's where we add, right? 1 plus 1, because each of them has an exponent of 1. Okay. 2x times negative 5.
2 times negative 5.
It's really 2 times negative 5 and then times the x. So after you do that, what's that become?
Negative 10x.
Negative 10x. Okay. And the next one, don't we need to rearrange it even? 3 times 4 is 12, and there's nothing else to multiply that x by, so it's 12x, isn't it? And our last one, last multiplication is?
Negative 15.
Negative 15. Okay. So ready to set up our addition problem. We have an 8x squared plus a negative 10x plus a 12x plus a negative 15. And as I said, typically you can combine the O and the I steps products together because they're like terms. Are the O and the I steps products like terms?
Yes.
Okay, so what does that become?
2x.
2x. We don't have a like term to combine the negative 15 with. We don't have a like term to combine the 8x squared with. And now cleaned up, our answer is what? What do we get for the answer for this one? Michaela?
8x squared plus 2x minus 15.
Okay, everybody agree with her? And this is FOIL. Welcome to the world